Okay, so this is another logarithmic differentiation problem that we're asked to do. So I'm going to immediately, and I'm going to try to use all the space I have here. I'm going to go ahead and take the natural log of y and take the natural log of the other side, which is 9x square root of 2x plus 1 over e to the x secant cubed x. Okay, so when I do that, the left side, there's nothing to it, you leave it. But the top, notice that there are actually, it's a product of three things. And the bottom is a product of two things. So let me take the numerator, which is a product of three things, and I'm able to write it this way. Using properties, natural log of 9 plus the natural log of x plus the natural log of 2x plus 1, and we're going to use the 1/2 power instead of the square root. And that's a minus sign because I have the natural log of, that was an e to the x, of e to the x. And then minus the natural log of secant of x cubed. Okay, so now I think we take one more line to simplify. Natural log of 9, that stays. The natural log of x, no problems with that. Here I need to bring down the 1/2 using the power property. The natural log of e to the x is x. And then this is 3. See, in terms of the natural log of secant of x. So I'm able to bring this 3 to the front. All right, so now we can work with this. Taking the derivative of this, it's 1 over y dy dx. The derivative of this is 0. I don't have to write it down. The derivative of this piece is 1 over x. The derivative of this is bring out the 1/2, and it's 1 over 2x plus 1. But I have to take the derivative of the inside function, and that gives me a 2. All right, the derivative of this function is a 1. And the derivative of this function, I have to deal with a 3. This goes in the denominator. And then the derivative of secant x, I put it up here. It's tan x secant x. I'm going to put it in the other order. Secant x, tangent x. And so dy dx, I still have to somehow deal with that 1 over y, which we'll do that in a minute. 1 over x plus, now if I'm going to leave this the way it's done in the book, I'm going to just, instead of, I automatically want to cancel these, which should work, but they have it this way in the Newton Alta program. So either one should be acceptable. The secant x's cancel. And so I'm left with 3 tangent of x. Put this in parentheses because what I want to do is multiply both sides by y. But instead of putting a y over here, I know y is all this stuff. And because these cancel, I can just delete them. And that is my final answer there.